angle. Yeah. Okay, so this is actually, well, you can write down projectiles. So it continues with what we've been doing. This lesson definitely will need to be continued next time, so we'll get a start on it anyways. In fact, this lesson usually takes 2 classes to do because projectiles is quite a difficult topic. So we can at least get a start on it to get the ideas formed.
Projectiles in which mechanics or materials?
What do you think? What chapter are we doing now? Mechanics? Oh, what?
I cannot see it. Oh, okay.
Okay, can I continue please?
Yes.
Projectiles, do you have this? Yeah. Yes, you got that written down? Projectiles. Okay. So really, I might not get a chance to do many or any examples, but at least we can get the definitions and vocabulary first. So, projectiles, this is motion in 2 dimensions is what we'll be looking at basically. So, if you think about it, so far our motion has been in 1 dimension. Either we're moving like this or this way. But now we're going to start looking at it in 2 dimensions then.
Like vertically or horizontally?
And horizontally, yeah. Previously it's been horizontally or vertically, whereas now it'll be horizontally and vertically. Both together, yes. Okay, so the formal definition of a projectile. A projectile is an object that travels through space with only the force of gravity acting on it. So, wait, just before you write this down, be clear. The only force on it must be gravity. So a rocket ship, a spaceship, is not actually a projectile because the engines. Okay, so just to be very, very clear, projectile, only the force of gravity. That's key, okay? It generally, but not always, travels along a parabolic path, which I'll show you what that looks like in a moment. Yeah, that's the shape. Yeah. Yeah. No. First you write, then you understand. And then if you don't have time to understand, you go to Starbucks, you get a coffee, you sit down, you open in your notes, you read, and then you understand.
And if you don't understand,
then you come see me.
No.
If you don't understand, you come see me.
What is parabolic happening?
Yeah, I'm going to show you the picture of that now. Yeah, it's okay? Yeah? Alright. Continue.
This is general.
It generally, but not always, travels along a parabolic path.
What is parabolic?
You're the 3rd person who asked me. So again, I'll say, I will show you the picture in a minute. Okay?
No, he's the 2nd person. The 1st person was Adnan.
No, the 1st person was Mir. Well, he didn't really ask me. He's checking, yeah.
So, what?
And the end is left.
Just, can you give him a slap on the back? Okay, so this is a parabolic path. It's a path that has this curved shape to it.
Yeah,
In fact, yes?
No, like in the race, someone rides a bicycle and girls like this.
Well, not just the bicycle race. Now, the parabolic path is this curved shape here that you see when you throw something. In fact, you have seen this shape in maths class already.
Yeah.
Quadratic equation.
Yes.
A quadratic equation is a parabolic path shape. This is exactly a quadratic shape.
Something is flying, then comes down.
Yes, I can see that, yeah. So I don't know if you want to draw it, But if you want, you can say it's the same as a quadratic curve.
Curved shape.
Yeah, but it, more precisely, it's actually exactly a quadratic curve shape. So you've done quadratic curves, and you've drawn them in maths.
Yes.
Yeah, it's exactly the same shape, exactly the same. Okay. So this is a projectile. Now it's a projectile, and you might say, well, hang on, is it? Because what forces are on the motorcycle?
Engine.
Yeah, the engine, but the engine stops being a force when it leaves the ground, because the wheels are just spinning. Yeah. So it's only the gravity force. Yeah. So the engine was a force until he left. Then the engine force is not relevant because it's doing nothing except spinning the wheels. You know. So this isn't a projectile. Yeah. And again, with a gun, when you fire the gun, there's a force, but the force is the explosion of the gunpowder. But that no longer is important after it has left. And that's all we care about. After it's left, is there still a force? If not, if it's only gravity, then it's a projectile. Okay? So next, this is projectile. Once the bicycle has left the ground, then it has no control over its motion. There's no longer any engine force. The only force on it is gravity. True, there's also air friction, but we'll ignore that for these problems. Next, we'll have a look at not a projectile. So this is not a projectile. Why not?
Because he can move.
He can move, yes. So he does not fly in a parabolic fact. He travels wherever he wants. Okay. Right. Now, some points about the motion of a projectile. So you'll need to bullet point all of these. Does anyone know what the first point means? The dimensions are independent.
What do you mean by dimension?
Okay. Dimensions, the x and the y.
The x is just the y, the change.
Yes. This is the x, this is the y. No, that's not what this
I
means.
think it means like it doesn't matter no matter how high it goes, like y
no,
doesn't affected by
Yeah,
it.
the y does not affect the x and the x does not affect the y. Okay, so if you know what's happening on the y, that doesn't tell you anything about the x. And if you know something about the x, it doesn't tell you anything about the y. Okay. That's the first point about motion in 2 dimensions. Okay, so the second point is the gravity is only on the y-axis. So yes, only the vertical feels the gravity, not the horizontal. Yes? Okay. Next point. Continue? Yeah. Right. There's no acceleration in the x. Yeah. So the x has no acceleration. Okay, you got that? Yeah. The next point is you can use vectors can be resolved, that can resolve projectiles into x and y. So just before you write that down, what I mean is if I was throwing something over here, it's a vector because it has a magnitude, which is my speed, and it has a direction, which is the angle I make with the ground when I throw it. You can use what you learned about the cos and the sine to resolve it into a horizontal and into a vertical component. So what I mean is when you throw something, you can take this vector and resolve it into a horizontal and into a vertical if you know the magnitude and the angle then, which you will be given. Okay, so you can resolve the vectors as normal. Yeah, that's okay. And then projectiles have no vertical speed at their maximum height. So when the and we kind of saw this with the bullets earlier, when the projectile is at its highest point, there's no vertical speed. But it still has a horizontal speed because it's still traveling through the air.
But when it reaches maximum, it's
The vertical, there's no vertical speed. Yeah? Continue? No? Yeah. Okay. And please remember again, do not forget, remember that S is a position and not a distance. And that is very important for projectiles. It wasn't so important previously, but it's now very important.
Position rather than like displacement.
Displacement, yeah. And the last point is worth restating. For example, well, we'll get to the example in a minute. Okay, so for example, if I kick a ball along a field, the SY will be 0 at the end of flight. So let me just draw that for you. Here, this is the SY, displacement vertically. At the end, the SY is 0 because it's on the ground. It has no height. Is the SX 0? No, definitely not. What about at the beginning? The SX is 0 and the SY is 0. And here at the middle, this is when SY is the biggest, so SY maximum. And the SX will be this much. This will become clearer when I do an example, don't worry. Yeah, I did. Right, so this will be a good example to put all these ideas down on paper. So if you can just carefully write this question down, it's our first example for projectiles. Okay, do you have this one nearly? Yeah. Okay. So, I think what we'll do is we'll just do this example and then we'll just leave it at that. But I really, because this is the first example, really just want to pay attention to make sure you have everything understood. Alright, are you ready for this one? Yeah. So, if you were to read the question, it says, let me draw it first actually. A projectile is fired at, what's
30 degrees.
30 degrees. So what you have here is something which is fired at 30 degrees, and the speed is
100 meters per second.
100 meters per second. So of course you know what will happen. It will move up in the air and then come back down and then land here, for example. Okay. So this is how I used to think about it in school, and I think it's a useful way to think about it. If you have something that's moving in the air, I'll show it again as well. So imagine that this got thrown up in the air like this, Okay? As it's moving in the air, can you imagine that there's a shadow on the ground, and there could be a shadow on the wall? So when this moves in the air like this, if you were looking on the ground, you see a shadow, a dot going across the ground. And if you, that's the x-axis. And if you were looking at the wall, what would you see? The y, what would you see with the shadow? You'd see a shadow going up,
And then down.
and then stop, and come down. And this is how I like to think about projectiles. Rather than one motion, it's good to think about it as two motions that you can look at. And you can look at each motion independently. So that's how we think about vectors. So the first thing we'll need to do is to resolve the vector into the x and into the y. So what is going to be on the ground? What is this vector? Do you remember how to calculate this?
It's close to the point design.
This is cos. So this is 100 cos 30, and then this one here is 100 sine 30. Okay, so well, yeah, what is 100 cos 30? It's 86.6 meters per second, and then 100 sine 30 is 50 meters per second. Okay. What do I ask? Oh, sorry, it's a little bit off the screen. What do I ask you to calculate first? The time of the flight. So I want to know how long until it gets to here. The time of the flight. Okay. So the way we think about these is, so this is part A. You think about them as two problems. A problem in the x and a problem in the y. So u, v, a, t, s and u, v, a, t, s. So let's look at the x first. Starting from here, the shadow moves along until it gets here. The u will be what? 86.6.
Oh.
Yeah. The v we don't know. The a will be 0. Because remember I said there's no acceleration in the x, only in the y. The t, I don't know, and the s, I don't know. Here, vertically, it goes up and then comes back down, the shadow. What's the u? 50, good. The v,
0.
we don't know. Oh no, sorry, it's not. It will be 0 if it was to go up to the height, but it's coming back down. So the v we don't know.
But is it the next, like the v is 0? Because it's not stop the thing.
Yeah, but it's moving with speed when it hits the ground, which is the v. After it hits the ground, it'll be at rest, but as it's hitting the ground, it's not. The a? No. Minus 9.81. Vertically.
Yes.
The t? We don't know. Now, think for a few seconds before you give me the answer. The s?
0.
Yeah. Because it goes up and it comes back down, so it's no displacement. Can I use this to find the t? No. Why not? There's only 2. Can I use this one to find the t? Yes. So we can find the t using this one. We'll use s equals here. S equals u t plus a half a t squared. Yeah? So we can get then 0 equals 50 minus 9.81 over 2t bracket t. I took the t out, it's in common. So I get 2 answers. T equals 0 or t equals whatever this works out at. 10.20. Now which is the right answer? Yeah. So this is the answer we take, and this answer we reject. So this answers the first part. So I'll give you a minute to write this part down. What did I want in the B part?
What is the range?
The what?
Range.
The range, yeah. Well, that's easy to get then.
Range of
The range, I'll explain what that is now, yeah. Well, maybe I might as well do it, because I'll try and keep it all on one screen. So the B part, when you're ready. Okay, let's start looking at the range. So does anybody know what the range means in projectiles or in English? If you talk about the range of a projectile. No. Just think about general English. Like if you can imagine, like even in a video game or a movie, if I
Average
said,
distance.
what is it?
Average distance.
Range
Maximum distance.
Maximum distance. Yeah, the range is how far it can travel away from you. So on the picture, if you look here, the range is the distance it travels this way. This is called the range. Can you see that there? That's the range. Yeah. Now, that basically means they want you, or I want you to find the S in the horizontal. Now that's actually quite easy to do because you know the T now is now 10.2. So it means, if you think about it like this, how long did it take the shadow to go up and come back down? 10.2 seconds. That's the same amount of time it took for it to go from here to here. You know, because if it took 10.2 to go up and down, then it takes 10.2 to go from here to here, because the ball is, there's only one ball. So if it took 10.2 vertically, it takes 10.2 horizontally. So this is 10.2. Now, is there acceleration here? No. So we can use our distance, speed, time triangle. So the distance is the speed multiplied by the time. And that's the range. 883 meters. Okay, and then finally, what do I want for part C?
Will have the maximum height.
Yeah, now in this case it will be half, but not in all cases, so I'll show you how you should do it. So now we're looking at the maximum height. So if we're looking at the maximum height, am I looking horizontally or vertically? Vertically. So let's only look at the vertical. Vertically. U, V, A, T, S. What's the U vertically?
U.
Yeah, vertically. 86.6. What's the V vertically?
You don't know.
You do, if it's maximum height, you do. 0. The A?
Minus 9.8.
Minus 9.81. And the T and the S we don't know. And this answer is going to give us the maximum height. The highest the vertical shadow reaches the ground. So what would be the easiest formula here? V squared? I think so, yeah. This is part C.
First we have to find T, isn't it?
We don't... Did I ask for the T or did I just...
the S anyway.
Yeah, I just need the S.
Yes.
That's the B part, that's the... And this is the A part, and now this is the C part. What will I use? V squared, I think. V squared equals U squared plus 2AS. 2AS. So S equals 382 meters. Yeah? Okay, now I want to give you just one question to do for homework, just to make sure you get this in your head, and I'll just write it on the board, okay? I'll make it very similar to this. Can I scroll down? Yeah? Okay. Yes, I can scroll down? Okay, so maybe you just want to write this in your book. So the
Draw this.
yes, yeah, no, you don't need to draw this. So the football is kicked at an angle of 45 degrees at a speed of, we'll say, 50 meters per second. So I want to know how far, or no, I'll keep it simpler, sorry. What is the range? So he kicks the ball up in the air and then it will land somewhere here. So the range is, I want, this distance here is the range. Okay.
Let's take a picture.
Yeah, that's fine. Actually, you know what? I'm going to just change this, make it a little, I don't want to make your life too easy. I'll call this angle theta. So I want to know what is the range if theta equals 30 degrees, if theta equals 45 degrees, and if theta equals 60 degrees. Yeah. No, it's more interesting because then you can see that the range changes with different angles, and then I would like to know which angle gives him the most range. That's what I'm getting to. You all feel like it should be 45. Yeah, so we can see the difference between 45, 30 and 60. So what is the range if? Okay, I think this is a good one to do. Yeah? Okay, when's physics again? Monday, is it? Monday, Wednesday, Friday, isn't it? Yeah. Ah, yeah, so you only have this one question to do, okay? So, on Monday we'll definitely have to do 2 topics in the class, but that should be no problem because I'll only have this to do as a homework. Yeah. And you know, if everybody gets the right answer, then I probably won't even do it then, yeah. Okay, we'll leave it there, so.